Okay, all right. Hi everyone. Welcome to Azure Databrick. Building your first data pipeline presentation today. This is the second installment of the Azure Databricks for Cloud Professional series. Today we'll be developing our data pipeline using Azure Databricks and Azure Data Factory. Before we begin, a quick introduction about myself. My name is Wilson Mock. I'm over 20 years of experience in IT. Currently, I'm a manager at Avalon in the data engineering area. Um, and prior to that, I was working at CAE as a lead data architect, as well as a lead AI architect at Air Canada. You can follow me at LinkedIn, C Sharp Corner, as well as GitHub as /Wilson-Mock. In this presentation, we'll be focusing on three topics. First, best practices on using different Databricks clusters and the costs associated to it. The intent there is for the basic understanding of when and what to use for each phases of development. We won't be spending too much time in this section here. The next part will be to develop our data pipeline in Azure Azure Databricks using Databricks Notebook and as well as the data lake format. Lastly, we'll be automating our data pipeline using Azure Data Factory. At the end of the session, you'll be able to use Azure Databricks and Azure Data Factory to build and schedule your own data pipeline. The knowledge level for this presentation will require to have familiar with Azure Databricks UI, basic PySpark, and SQL as well. This presentation will have two demos. The first demo after the first demo, there will be about 5 minutes Q&A sessions, followed by a longer Q&A sessions at the end of the presentation. All the code you see today will be available on my GitHub repository as well. So a quick recap on our last presentation. So we went over the Databricks UI. We created a simple notebook which allow us to monitor the power consumption for the power company that we're working for. And finally, we created a personal cluster for the notebook to run. So a personal cluster is one type of cluster that Databricks provides. Databricks actually provides three types of clusters to help you develop your and deploy your workload. So the three types of clusters broken down into two major area. The job area, which focuses on workload that are scheduled and run automatically. We can run the whole notebook, and the cluster will be terminated as soon as the workload is done, has been completed. The benefit of running a job cluster under the job area is to provide us with lower costs overall in the using the cluster. And the recommendation there for this workload is to right size the number of workers inside the cluster so that there are a stable processing taking place. We do encourage auto scaling if possible, but not we try to keep that at the minimum if possible. So the next major area is the interactive or all-purpose section, and in this area you can open a Databricks notebook and run each cell one by one. Unlike the job cluster, where we have to run the whole notebooks as a whole, in here you can run them at each cell at a time. Because of that, you have the ability to control the cluster, so you can start it, you can terminate it, and you can define how long you have until you will auto shut down the cluster. It might be easy to configure your cluster to have a 1+ hour timeout, as some company we have seen, but this is not a good idea as it will cost a lot of money. So The best practice here, probably leave it between 15 to 45 minutes, depends on your purpose. So inside each of the, excuse me. Inside the interactive or purpose cluster, there's two subcategories, and that's the share high concurrency cluster as well as the single user standard cluster. So the shared high concurrency cluster there, this is the intent is to share this cluster with multiple users. So a good scenario or use case for this would be for data analytics, where you're doing a lot of data analysis, and when you started doing data exploration, when you try to find out how useful is this data set to your analysis or machine learning purposes. So the reason why we want to share this cluster here is we expect the data to be accessed by multiple people. We're recurring similar data sets across multiple people doing the analysis. Again, user have full control of the cluster, so you can start it, you can stop it on your own. So, but just be mindful that you share across multiple people. So you might not want to shut it down when just because you're done using it, but other people might be using it as well. So the recommendations there is using a larger virtual machine with less workers. And the benefit of that is you don't have to rescale or auto scale your machine as often, which provides you with a more stable um, uh, user experience when you're analyzing your data. So generally here, you will probably use a higher timeout limit here because there are multiple people using it, and you don't want to be having this cluster turning up and down at the same starting, scaling up and scaling down all the time, the yo-yo effects of that. So finally, now there's a single user, the standard cluster that often is being referring to. So in our previous presentation, we talked about a personal cluster. So that would fall under this category. And the use case for that here is it's primarily used for development and for performance testing. The performance you get in this cluster will be mirroring the job cluster experience that you have. Again, except you can run the cell one by one individually in a notebook. So depends on your solution. The recommendation for the virtual machine really varies, depends on the type of workload you're doing, the size of the workload, and the complexity of the workload. We'll have a little more detailed breakdown of that in the next slides there. But this one's highly varies because it is for your full development purposes. And yeah, so the main goal here is as part of the performance testing after development, you're trying to assess your workload so that you know what kind of number of workers you might need for this cluster, that you can transfer that setting over to your job cluster. So as part of that, in the cluster, there is actually two components that comprise of the cost of the cluster. So there's the VM or the virtual machine charges, as well as the Databricks unit cost, which is the DBU cost. So in Azure, they provide different types of virtual machine to help you manage your workload for different purposes. And we'll quickly kind of go over each one and talk a little bit about the cost more in a summary purposes here. So as we quickly touched on, virtual machine cost is the cost that you are using the virtual machine like you would when you create an Azure virtual machine separately. So there's no cost differences there. The Databricks unit cost or the DBU's cost is what Databricks charges you for using their service. And the charge is based on the processing capacity capability of the machine. So Azure really broken that down into three different categories: the general purpose, the compute optimized, and the memory optimized category of clusters. So I took a machine that's a 4-core to use an example for each one of those VM types here. The higher the VM core or the RAM, the higher the charge it is naturally in the caused by a virtual machine. So the spec for the general purpose machines are usually relatively balanced between the CPU speed and the RAM. And as the name suggested, is general purpose. So usually when you start your pipeline development and your data analysis, you will start with a general purpose machine. The next category is the compute optimized. And in this specific area, you have a higher speed CPU, but you have a reduced size in memory, as 8 megabytes in this example here. So anything that you do heavy calculation wise, for example, when you're doing sums, you're doing average, you're sorting your data, um, that would be useful in using this type of compute. Now, because of the reduced amounts of RAM or the memory, you have to be very cognizant in terms of how big your data set or how much data you're joining together. So simple join is recommended in this particular use case. And finally, we'll have the memory optimized. And as you can see here, is significantly bigger than what the general purpose has, even though it's still running 4 cores. And as a result of that, you can see the cost also is bumped up of that. So this memory optimized cluster or the VM is very useful when you have heavy data manipulations and complex joins where you're joining multiple big data sets together. So so with that in mind, we broken it down into two separate cost area. So both the general purpose and the compute optimized for a 4 core machine charges Databricks charges 0.75 dBu. That's how they measure the processing capability. Where, as you can see in the last row there with memory optimized, that is significantly high. It's 1.5 dBu charge. And the total cost on the right-hand side also translate that cost across. And you can clearly see there's a difference between an interactive and a job compute or the job cluster that we mentioned just a second ago. And approximately overall, you would save approximately 45% less charge than an interactive cluster. So so it is ideal once you kind of figure out how your job will run, the performance of the job, that you switch over to from an interactive cluster to a job cluster in this area. So now let's imagine a time when your boss asks you to create a data pipeline to track the power consumptions every hour. So you have data arriving every 15 minutes. You have 9 big power stations that you work on, that you work with. And each station will send the power usage information to the data lake themselves. So this data happens to be in a JSON format, which is great for Databricks to to access. Then how would you go about creating that file where it allows you to access the data, and then more importantly able to access the data efficiently? So as you can see, when you have 4 files every hour with 9 stations, that's 36 files you have to read in and process every hour, and that can be quite expensive, and especially if it is something that you need to do frequently, on the every hour you need to refresh this data. So the first idea you might have is to create a single hourly file. So you read in your 36 file every hour. You would create one output hourly file that you read off of, and this idea is great in the first glance, as you reduce the amount of file reading from 36 to 1 for every hour. Now, some of the challenge that you might encounter, and often this is a real very common use case, is what happens when your data arrive late. So in this case, if you're generating one hourly file, if you have missing data, then you have to reread the whole hour worth of data in order to produce a new hourly file, which contains all the data that you have. And another challenge that you might face is, what if you want to start looking into data that are spanning across a larger time span? So, for example, if you try to do an analysis across multiple months, or looking at data that's across multiple years. So we kind of run into the same problem again, as we're reading in smaller 1 hour of the hourly file, um, and not having a bigger aggregate that we can work with, or the bigger um, data set that we can work with. So is there a better way we can approach this problem than creating one hourly file? So Databricks has released a format called Delta Lake format, and it provides a table-like features without the downside of the traditional database system. So it gives you the table-like functionality, but not the concerns that you might have with a traditional database system. So some of the concerns that you have with a traditional database system is you have a very tightly coupled database with your storage system, right? And the cost of the licensing is usually very expensive, and it often charges by the CPU, or the number of cores you have running on the machine. And lastly, one of the most important thing is, once you stop paying for the license for the database, you also lose access to your data, which it doesn't it compounds the issue for you later on. So the benefit of the Delta Lake format is, it gives you just like a traditional database, like table feature, but and you can make the changes that you need like a table would. You can do your update, do your insert, do your merge of your data without having to reprocess all the data altogether. So some of the benefit includes, in general, with the whole Databricks and Spark concept, is we have a low cost storage underneath, which can help us reduce the cost of the data storage that we have. We also, the Delta Lake format is built on top of the Parquet format. So this format has built-in data compression, so we can store more data into each of the files that we create. And finally, the Delta Lake format is an open source format, which means you're not locked into one specific vendor or cloud products to access this data. So some of the example you can use to access the Delta Lake format data is, you can do it in Azure Synapse Analytics. You can do it in Databricks. You can do it in any Spark services. Either you spin up yourself, or it's a managed service like even AWS EMR. So all of those services have the capability to read and write the data in the Delta Lake format. As a result of that, we create an efficient pipeline that gives you the flexibility to use different cloud services in order for you to manage your costs, and as well as meet your targeted solutioning needs. So in our first demo here, we're going to dive into creating a data pipeline using Databricks, Databricks Notebook. So we have our data landed into a container called landing. So all of our data, the Power data, is in actual JSON format, and they land into our data lake every 15 minutes, as we talked about a little bit earlier. We're going to ingest this data, we're going to read it, and then we going to create an IoT smart grid delta table, essentially, under the processed container. And this data would, this format now we can If there's data that happens to arrive late and whatever not, we can merge the changes in without rereading the other components of the data that comes in. And finally, we can also process this data, make it available in a dashboard notebook, in a notebook that has a dashboard built in, um, that can access the Delta table directly. Okay, so let's switch over to the Azure environment here. So as you can see, I generated a bunch of data in this is our data lake landing container that we just talked about a second ago. And I generated a set of data that's available in here. So for example, this is the year 2023. Basically, January 1st is the folder structure that I have. And for each 15 minutes, a folder is created to store the 9 different power stations data, as you can see here. So this is at midnight, and then this is at 15 after midnight, essentially. So all of this data will need to be processed by our Databricks notebook. All right, so now let's launch Databricks, and let's take a look here. So I'm just going to navigate to the notebook that I already have prepared for us, and we'll kind of talk through the notebook, step through each of the cell blocks that we have here. So I'm just going to start up my cluster here. It's going to take a little bit of time to get started here. So we'll start kind of talking about the first couple of cells, and then once the clusters start, then we'll catch up, let the running catch up. So really, at the top of the block here, we're just defining our purpose for this code. So we will retrieve the JSON file as we talked about from the landing container. We'll create a parameter or widget in this notebook so that we can change which files to read as required. And that will allow us to easily reuse this code for different time frame the data will come in, or different schedule the data will come in. And finally, we will create the IoT smart grid power consumption table if the table doesn't exist. And then if there's any new data coming in that we need to merge the data in, the data will be made also available in the table as well as in the written into the storage account. So in order to not expose my password or the account key of my data lake in the notebook, I set up a secret that contains my account key. So so pretty much in the first code here is very similar to what we have seen in the first demo. In the last presentation, if you were part of that presentation, essentially the focus here is talking about how we just need to configure the Spark in Databricks so that they know what the password is or the account key is for my storage account. So oops, that sounds like I ran that already. So if you're resetting the demo, so I also commented this line of code here. So you can, if you want to run this demo yourself, and you want to reset it from scratch, you can easily uncomment the line of code here and then run it. Since I have already reset my notebook, I'll keep this line of code commented out, as we don't need that. So the next block of code here is the dbutil command, which essentially in this case, we're asking the notebook to add a widget, or in our case, a parameter. So as you can see, after this block has been ran, a little panel came up on the top here. So this is the widget or the parameter panel, and we defaulted with January 1st midnight as our starting folder structure. So command number 5 here, our focus is to start reading the data in. So so essentially in here, I define the landing location at the second command here that tells me exactly where the data is located, at least the parent folder. And then I use the dbutil.widget.get command um, on the landing folder to get me this path, this folder path returned to me. And then, as we discussed before, all the files underneath is going to be JSON. So it's just going to go /.json there to read the files in. So the next thing so we can take a quick look at the schema of the file. We won't spend too much time analyzing the data itself, as we did that um, in the previous meeting there. But one thing to note is our measurement date happens to be a string and not a timestamp. So that's going to cause some issues down the road for us. So we want to convert the column essentially from a string to a timestamp. So that's just a simple command with a data frame dot with column to make the change. Okay, now we're in block 7 or command 7. So in here, it's this is where the bulk of the work is going to take place. So and this code looks a little bit different than if you're traditional familiar with the spark.read command, as we're going to be building this using the delta tables. So in order to do that, we can just call the from delta table.import import star. This is a built-in library that Databricks has made available for all their clusters, so you don't have to add in any separate libraries in order to make that work. The next command on line 4 here is to check to see if the location where our data is we want to write to is actually a delta table or not. Now, if it's not a delta table, then we want to overwrite whatever that's there and make it a delta table. And if it's a delta table, we really do not want to overwrite the table because there's data already existing from the previous load or previous runs, for example. And you might have data that are just missing that you're just reading back in right now. So in that case, we want to leverage a command called merge. So delta table, similar to your SQL, you can merge your data set instead of having to read the whole data set in and rewrite it back out. So here it just simply says that we have we're going to read in our data from the previous location, from the process location. Okay, and we're calling this data set a target. We read in the cell above, we read in our data, we call it the grid data data frame. So we're calling this data frame source for short. So what we're doing essentially here is defining the condition that the merge command will use to identify if this record is new, has updated, or has been changed. But in our case, we only really care about insert. There should be no changes coming in. So basically, this is saying if the date of our data is the same and we're working with the same meter in the power station, and this is writing to the same, having the same zip code, then if all those things are true, then if we do not have a match, then we want to insert this data. So that's when no match insert all command it's being called. Okay, so in this case, since we don't have anything in our process location, when I run this, we should expect the delta table to be created first of all. So it'll take a few seconds here to get that ran. Okay. So this table should be getting written out right now. We can quickly jump over to our storage account and take a look at this table or the delta data getting written out. So under the process container, we have the IoT Smart Grid folder, As you can see here, the data is just written out just now, like a second ago. Okay, so now this is great. You have this data in your data lake now. Other people can access it, and can work with it. Now, that's not the easiest way to access your data and to build a dashboard out of it. Um, a lot of the tools still, very focused on using SQL as the tool that we build dashboard with. So one of the way to do that is we can create what we call an external table. So this command basically says, I'm going to create a table in Databricks using the location that are in the storage account. So when the data in the storage account changes, the results in the table also changes, and vice versa. If you make a change in the table, the the data that's in the storage account will also change. Okay, so now we're moving to command line here. Um, so in here, we will use the SQL command, describe extend. That's Let us take a look at some of the details that this table has. So given what we just ran on line command number 4 in command 8 earlier, we should expect to see this to be pointing to the external storage account. And since we're reading the data out as delta, it should show that as well. So as you can see here, this is defined as the type external. It is an external location on the data lake that we define as expected. And the provider is a delta format that we have here. So we can see this confirms that our data is actually stored in the data lake and not stored in the internal storage that's being used by Databricks. So finally, the last item here, just want to quickly show you, is the transaction log or the versioning history that you also somewhat expect to see in a table-like structure here. So as you can see, this is very straightforward. We created the file using spark.write, and it has 180 rows in there. So you store them in 3 separate files, and it was written out. So now, what if I rerun we run command 7, where we have this check to do the merge versus the write. If I run this again, would I would expect that there's no changes that taking place, um, and we should expect that there's a tracking that tells us that we ran a merge, and no data has been changed, because we're operating using the same data frame, um, the same source data from the grid data frame. So that hasn't changed at all. So now we scroll back to command 10, we'll run this again. Now you can see there is a version 1 now that's has a lot more information in the operational metrics. But the main key things we want to take away here is there's no row inserted, no row updated, and no row deleted. So basically, the Delta format took a look and say, yes, this is the same file, same data set. There's no changes that's required from me here. So you can see this can be very powerful for us if we're making a lot of changes very often. Um, we don't have to create a daily file that we have to manage and worry about if files are coming late and your data is incomplete. It's just add those new data in when they become available. Okay, so now let's do another example very quickly here, where we're going to read in the next 15 minutes worth of data. So if we do that, all we have to do really is execute command number 5 again. Technically, you can rerun the whole file, but just for a quick testing that you would do normally on your own, you would change this to the 15 mark and just run the cell that will be impacted, right? So as you can see in this case, looks like a merge operation has ran again. I'll run command 8 again. Now we should expect your schema and your structure hasn't been changed at all, because we're using the if not exist command here, which means if the table or the schema already exists, you will automatically bypass it. Okay. So now we're back in the command 10 again. Now I would expect we have another 180 records being inserted, and a new version has been created for the new entry here in this case. Now, so as you can see, version number 2 has been created, and we have 1080 row has been inserted into the delta table. And the first column here shows you the number of row that's being outputted. So it could basically, it's a combination of the insert and the update in this aspect there. Okay. So finally, we're going to do a quick check on our data. So again, we probably, generally speaking, we should comment this out in production. We don't want data to be outputted in our notebook if possible. But for testing purposes, it's perfectly good. So as you can see here, we're having data coming in. There's about 6 rows of data, ranging from, maybe I should just do an order by here to make things a little more clear. All right, so we have data coming in every 5 minutes in those files that they saved up. At 05, 10, and 15, it looks like those are all stored inside the midnight folder. And then the 20, 25, 30 is a second batch of data that we processed, and they were read in at the 15 mark folder there. So yeah, so that's how you would be able to utilize delta table format to simplify your data processing aspect of the work. Okay. So, and we need to, sorry about that, jump over to take a look at another notebook, which I'll just open quickly here to show you. So this notebook here shows the has the dashboard created inside the notebook. Majority of this code is actually in SQL, except for the first command that really configure our setting again, so that we can read the database table that we created in Databricks. Okay, so instead of running each block one by one, I'm gonna go to View and select the dashboard called Demo2, and then I'm gonna tell it to run all. So this is the visualization that I set out earlier, and that I laid out on the screen earlier, in pretty similar to the demo one that I did in the first presentation. So yeah, so as you can see here, we can see there's 3 area interests that I'm interested in, and that's each of the zip code in this region of the United States. And I can see, as we saw earlier in the first notebook, where the data are reported in what the value are for the first 30 minutes of the data, and it shows different different up and down that we get in the power consumption there. Okay, so just switch way back to the code here. There's nothing fancy in the code here. We'll quickly step through them. Pretty much the top box here, all we did was doing as aggregate at the sum on the kilowatt usage that we have, based on the time frame that we defined. The next one is the map visualizations. In this, I just group the data based on the zip code, the lat and the long, and the usage that they have for the duration that we're interested in again. And then finally, the last query that we have here is pretty similar to above, except we're more focusing on the measurement date, where we can start segregating each of the zip code data um, by the data by the power consumption that we have for each of the zip code data there, based on the time span that we have. Okay. So yeah, so that's kind of the output of the demo. So as you monitoring the data after we schedule the pipeline in a bit, you can run this and see your total power consumption on a regular basis. So now the last part of the presentation is focusing on scheduling and automating our data pipeline in the notebook that we just created in Azure Databricks. We'll be using Azure Data Factory in order to do this scheduling purpose. But before we dive into that presentation, I have delivered two other in-depth presentations on Azure Data Factory previously on Dear Azure, and they are the created data pipeline using mapping data flow in ADF, and as well as the CI/CD for Azure Data Factory using Azure DevOps. So if you're interested in more in-depth topic of Azure Data Factory, feel free to dive into those two presentations where you can learn about the low-code Spark service inside Azure Data Factory and Synapse, and as well as how to use them CI/CD to deploy your data pipeline in Azure Data Factory. Okay. So, Azure Data Factory. Azure Data Factory or ADF is a service that allows you to manage your data processes. That's one of the main components that they have. And in Azure Data Factory, a pipeline and have really five components inside Azure Data Factory. So the pipeline itself contains a set of tasks that's to be ran. So we can define each of the order of the task that we want to perform in this case. And the task is in Data Factory, they're called activity. So each activity will perform an operation. So for example, in this example here, activity one will run first, so the task one will run first. And then after the task one is successful, then activity two and activity three will run in parallel at the same time. As soon as activity two finishes, then activity four will start its work, and then the whole pipeline is completed once all the activity inside of it is completed. An example of an activity could be you could be extracting data from Azure SQL into the data lake. That's an activity. When you're executing a Databricks notebook, that's also an activity as well. So inside each activity, we need to know the what and where to execute the operation of the work that we want to accomplish. So the where, that is really the links, what we call the link service, and this contains the connection information to other services. An example of that is a link service to a SQL database would have the server name, a username, password, for example, to connect to the database. The what, in this case, or the data set inside what we call in Azure Data Factory is the data that we want to access, that we want to use. So this could be, in this example, can be the table one that we want to retrieve from the MyDB database, or this can be as simple as a folder that's in your data lake or a file that's in your data lake as well. And finally, the fifth item, major component, is the trigger. So the trigger is a scheduler that tells the pipeline uh, when to run and how often it runs. So there's two groups of schedulers that's available. There's the time-based scheduler, which we'll explore more today, which basically says you need to run it every day or every Friday at 5 p.m. Or another time-based scheduler could say run this pipeline every 15 minutes, as an example. And the events-based scheduler would one use case is to detect when a file's landed on data lake, then you automatically start the pipeline for that file. That's another type of trigger that's available in Data Factory. But for today, our focus primarily will be on the time-based trigger, use case here. So for our demo here, it's going to be has a quite a bit of moving parts here. So we want to build a pipeline that first check to see if the file exists in our data lake. There's no point of starting a Databricks notebook if our data is not available in the data lake. That could be because it arrives late, or if because the data just there was an error in the system, right? Just the data is not available. So we're not going to start up our Databricks workload until we know for sure that the data is ready for us to process. And then when the activity has been completed or the task has been completed successfully, then we will execute the Databricks notebook and then also execute the notebook dashboard that we saw earlier. And the link services that we have in this demo would be connecting to the Databricks and connecting to the data lake. For the data set, we will create a data set to check the data folder, or in this case, the time folder, to make sure that the JSON file exists inside of it. And finally, we want to have a trigger that runs every 15 minutes in order to pull the latest data into our Delta table as soon as they're available. Okay, so let's jump back over to the Azure environments here. Okay, so let's go. All right, so let's launch Azure Data Factory Studio. So there's a few tabs that we should be aware of on the left-hand side. So there's the author, the monitor, and the manage. So author allows you to create your data pipeline and then your data sets inside of it. Where monitor allows you to check how your pipeline is running. Has there any failures or things have been running successfully? And finally, manage is the tab where you set up your link service and you can create triggers in that area as well. So for our demo, we'll dive straight into the link service first under manage. So as you can see, it defaults selected to the link service, but if you ever need to change the selection, is this item here. So in this demo, like we talked about quickly earlier, in the earlier slide, there's two link services that I already have created. So I'm going to create a very similar connections to the Databricks one, as you see here, just to show that how this would be created normally. So we will click new. In our case, we'll navigate to the compute area, and data and Azure Data Factory separate the two different areas, the data store and the compute. The data store contains a lot of the storage accounts. Azure SQL will be in here, for example, where the compute focuses on just things that has a execution attached to it, essentially. So select Azure Databricks in this case. Um, I'll just give it a quick name here. So in here, it's good to have a naming convention. So one way to do this is you denote the service type that you have. So in this case, I'm using Azure Databricks, ADB for short, as the prefix of the link service. What's the purpose of this data brick, right? In this case, is the IoT smart grid, and then underscore ls for link service for that. If your Azure Databricks is not really feasible by you because there's a management layer that abstract you from able to see all the configuration in the drop down list here. You can enter in the Databricks URL and configuration manually. But for us, in our demo, we can see our Databricks workspace. So we'll just simply select that. The next item here is the authentication type. So we're going to use the managed service identity, which is basically the authentication that is built into our service, and Azure provides the services to integrate with each other. And it's very common that once you select this, you might have issue for the items to come up below, because sometimes they don't sync up kind of properly. So if you ever run into that scenario, you can easily just switch the type of cluster you have, and the data below will get refreshed. For our demo purposes, in order to not for waiting for a lot of the virtual machine spin up time, I'm going to use the instant pool, which basically I have 4 virtual machines standing by for me to kick off the job so that we can see the results a little quicker in here. So for that, I'm just going to select the demo pool. You don't have to do this. You can easily select a new job cluster for your scheduled workload. As we talked about at the beginning of the presentation, I would not recommend we select the interactive cluster here. You would only do this really when your code is still going through a lot of changes, or you just want to test to make sure that the integration running your notebook is perfectly good. You normally, once you have everything tested, you'll be either job cluster or you will be running your cluster off of an instant pool. So let's go back to the instant pool here. We're going to select, in this case, 12.2. And we want to really use the cluster version that has the text LTS on it. And that really means it's a long-term supported version that Databricks provides. As you can see here, there's, even I believe like version 13 is even available. But since they're not a long-term supported version quite yet, we're going to stick with the 12.2 for now. So we're also going to select Python version 3. And this is where we spoke about a little bit earlier about auto scaling during the beginning of the presentation. So you can either define the number of workers. From your testing, you would know the number of workers you need. If there's some jobs that are kind of varies, depends on the size of your workload, you might opt to do auto scaling. But if you do, just try to keep those ranges to the minimum, if possible, because each time you scale up and you scale down, the yo-yo effect, you will delay your processing time frame. For the demo, all we need is really just one worker here. So I'm going to click on test connection to make sure I have I am able to connect to Databricks correctly, and it looks like it is. So then I can click create on that, and that will be created. So you can also publish this change out to Azure Data Factory. And if you want, you can also set up a code repository, a Git repository with this. So I have done that in some of the previous presentation I referenced to earlier. So we won't be doing that in depth in this presentation, but it is a good practice to set up your repository for your link services and pipelines and so forth. Now with the link service created, um, I actually created another link service, which is the storage account to my data lake. Again, it's going through a very similar process. In here, I select the data lake from the list, and also use the manage identity as well. So nothing tricky here. It'll be pretty similar step that you went go through to set up the Databricks connection. Okay, and with that, let's navigate back to the author tab. So the author tab, as you can see, there's different items in here. Our main focus really is going to be the pipeline piece. So let's create a new pipeline. I want to call this, let's say, the test processing power usage PL. So this is just a test um, pipeline that we're going to build really quickly. And then the underscore PL stands for pipeline here as a good naming convention to use. And here, all we really want to do is just start the development, right? We know the link service work, but we want to make sure things uh, can be ran correctly. And we're not going to face any issues before we full blown build out the pipeline. So the Databricks menu items here for the task or for the activities is under Databricks. And for this particular scenario, we'll be using the notebook. This is to run uh, process landing data. Let's say, right? That's the name that we want to give it to this activity. There's a few tabs here we need to configure. So the first one we need to configure is the link service we want to use. So let's pick the link service that we just created. Again, you're free to test your connection again in case you're worried about there's a connection issue. And then the next item is the settings. So this is where you can select um, your notebook that you want to run. Okay, so we're going to quickly navigate to the 2.1 notebook, which is the one we saw earlier in the first part of the demo. As you recall in that notebook, if I can just click open here, it should bring you to the Databricks notebook. We have this landing folder um, parameter or widget that's defined in Databricks. So we need to copy that out and put that into the parameter base parameter um, area. So you want to set this up so that for our test, we're just going to hard code the path that we want in our system. So since we did the 10, we did the midnight, we did the 15, we can now do the 30, let's say, and that will ensure that this is going to work before we go and build out our pipeline. So without setting up the triggers or anything, because everything is kind of hard coded in here, we can simply just hit the debug button, and that'll just run the notebook directly and call Databricks to create a job cluster, and then they can process the data for you here. So probably gonna take a minute or two to get started. Okay, so now this is in progress. So what we can do here is mouse over the process landing data. Oops, there's a typo there. And then click on the detail. So the detail would actually give you a link back to Databricks. So when I click on this, it will show you the notebooks being ran right now. So it looks like the cluster is just being spun up at the moment. So this is gonna take probably a minute or two for this to complete the process here. Okay, so it's like it's being ran right now. So you can even look at this live right now to see it run. You can see this cluster got spin up. The status is running now and has been running for um, almost a minute and a half here. So it looks like the commands are kind of flying through really quickly. Okay, looks like they are running the merge at the moment. We do expect a new version to be created, and we hope to see that output from this notebook as well. Also, it's good to note that we can see the parameter we passed in here as well. So if you are ever unsure what's being passed in, all the information should be on the right-hand side of the menu here for you. Okay, so let's see. So in this case, our version 3 has been created and our data has been inserted as well in this area. And now we have 9 rows instead of 6. So that means our data has been processed. So let's jump over to the dashboard again, right? We have 876 the last time we ran. And let's see what we get if we run this. Oh, it looks like our cluster expired. So that's gonna take a little bit of time for this to run. We'll come back to this in a second here. Give it a few minutes for it to start running. So we'll jump back to Azure Data Factory for now while we're waiting for the notebook to run, the dashboard to run. We can see this thing finished running and it succeeded. And we also saw the results. It took about a little over 2 minutes to run. And then you can expand on any of the detail, like this is the input, this is the output. It tells you how much cost it took for you to build this pipeline in and run this pipeline in Azure Data Factory. Still starting here. Okay, so since our testing goes well, let's build out the pipeline that we talked about in our demo slides there. So this is this is going to be the pipeline that we will have. There's quite a few number of components that we need to talk about. So the first thing notice is this top part here is much more complicated than our quick example that we put together. The second thing you notice is there's a parameter getting defined. And the reason we define a parameter is because we need this parameter to we need a trigger to pass in this parameter so that we know what folder to run, right? As the trigger is the one that manages the different schedules and the different runtime that we have. So we need a way, similarly to the database, we need a way for the trigger to call this pipeline with this configurable information. So Yeah, so that's the parameter there, and then the next item here we have is set variable. So you can create a set variable under general set variable. So and what I have done here is I simply defined a variable for the folder path location. And the reason we did that is in the set variable or in the time the the trigger comes in, the trigger start time, um, we need to subtract 15 minutes from the trigger start time. The reason why we need to take away 15 minutes from that time is because when the power station sends the data um, from 1 o'clock to, let's say, 1:15 in the morning, that data into the data lake, that data is actually stored in the 1 a.m. folder. So we need a way to run the pipeline at 1:15 when the data arrives, but reading the folder that's at 1 o'clock essentially. So by subtracting the 15 minutes away, it gives us the exact time that we're looking for. So the next item here is called get metadata. So that's also under general, and this is a good way for you to obtain many information that you have about your file or your folder, or even some database use cases that you might want to have. But for us, our simple use case here is to check to see if the folder that we need to access exists, and that's done under the setting item. And now in this case, we need to create a data set. So let's open the data set that I created. Um, Again, this is a very simple data set. We selected the data lake service that we created earlier, that we tested earlier as well. And we know this data is going to be in the landing container. We need to define the folder path that comes in. Now, as we talked about, this folder path is really a parameter that changes every time the trigger is ran. So naturally, we'll go into the parameter tab and define the folder path. And we'll come into here and basically select the folder path as our expression that we want to use, or the variable that we want to use. So with that configured, then when you come back and select this data set, the data set property will be available for you to put in. So for us, it's pretty straightforward. We have the folder path already. All we really need is to um, concatenate that with the parent folder, which is the smart grid data folder that you need to put the two together to get you the proper folder location. Okay. Now, now we need to know if the folder exists. So in the get metadata, there's a lot of different configuration you can use in the argument list. But for us, we're not doing much complicated check. All we're checking is, does this folder exist or not? If it doesn't, then you'll return false. If it does, then you'll return true. Okay. Now it gets into this funny big blocks of code here, and this is really just a if statement that checks if whatever is being returned by the get metadata. And you can find this if condition under iteration and conditions, the if conditions here, and you'll have the true and the false block. I'll go into the false block really quickly, as is the most simple thing. Really, it's under general fail. So if the folder doesn't exist, you're just going to fail with 404, which means file not found, as the standard HTTPS HTTP code. And then if it is true, then we will process the data and refresh the dashboard. Very similar to what we have done earlier, uh, but we're using the demo link service instead, pretty much here. Okay. And in the dashboard, there's no parameters because we're just refreshing based on what we have. Okay. So now with that all built out, oh, okay, so it looks like the cluster has ran. Just jumping back and forth here a little bit. And the number of power consumption went up from I think 800 and change to just under 1300 here. Okay, sorry, jump around there a little bit there. Let's go back to the Azure Data Factory here. So with all that changes, now it's time to to create a trigger. Okay, so we're really close to the end here under the trigger. So we'll go back into the manage. We can define a trigger. Right now, you can see there's no trigger available. We can click new on the trigger. And in this case, we also want to keep our naming convention. So for me, I just call it the demo underscore process power usage underscore tr for trigger here. So we discussed earlier, there are multiple types of schedules. So for us, for the schedule, this is like you run at 5 p.m. on every Monday. Tumbling window is the one we're going to use. Basically, we're going to run this pipeline every 15 minutes. And then the other two are event driven. So the storage events is when a file landed into the data lake, for example, and a custom event is something more advanced to do with the data grids that we probably won't be able to cover today. So for this, we want the start date to be January 1st at 0. Again, this would be 15, as we talked about earlier, not at 00, because the first batch of data arrive, it's 15 minutes after midnight. And I want this to run every 15 minutes. And I'm going to specify an end date because just for the demo purposes, I don't want this to run kind of forever here. So we'll specify a time here to be, it's kind of hard to see, to be 15, just so you will just end tomorrow sometime or on Monday sometime here. Don't want this to keep running for a long time. So you can also start this trigger on creation. For us, we're not going to do that because we still need to associate this trigger with the pipeline. And remember, we need to pass in the parameter from the trigger to the pipeline here. So I'm just going to create this trigger. We have the status is stop, which is perfect. I'm just going to, again, just do a quick publish of this trigger. And what that does is really pushes all the data out into the data factory's internal storage there. Okay, I'm going to go back to the author, go back into our pipeline. Now we can add the trigger here. So we can add the trigger, new or edit. In our case, since we just created it in the other screen, we're just going to select the trigger. So everything looks fine based on what we define here. So we will be starting this, but before we can do that, we need to pass in the parameter. So the parameter that we're going to pass in here is, it's going to copy and paste that in. So pretty much that's all it's saying is the trigger has a output window start date, or start time in this case, sorry, which contains the date and the time. And we're going to pass this in as into our parameter here. So we be careful with the warning here. Make sure to publish the trigger to be activated after clicking OK. So we're going to go OK. And then in order for this trigger to work, we actually have to publish this change. So it's going to give it a second here for the deployment. All right, so deployment has been done. So now if I go to the monitor tab, let's see here, maybe not 24 hours. I was doing some testing earlier today so that there's a lot of pipeline that was scheduled out. So if you look at this, we have a schedule. The pipeline's been scheduled out to run every 15 minutes, as you can see, and all those are just kind of queuing up for them to run. And then this is the only pipeline that's running because we configured it to run not in parallel. So just individually one by one. Now, this might not be, if you're doing historical load or loading old data that already exists in the system, you might want to allow the parallel run to take place because Delta Lake format do handle um, multiple processing at the same time. They'll make sure the data doesn't get corrupted and they come in the correct order. But in my case, I just configured it as to one for simplicity's sake here. We can also click on the parameter item here quickly to see what the trigger start time that we passed in. Let's see, even it's important to note that even this pipeline started on April the 28th. The input day is the 15th, which basically we're running the midnight data that came in. Okay. So again, similar to before, you can easily click on the pipeline name and you will load this information up. Exactly like what you saw before with your test pipeline. In this case, there's a few more items here, as you saw, right? So we are checking if the folder exists, right? The block here looks like it is, and now it's starting to run the notebook. So again, we can do the same thing here. Click on this, and the detail and get to the work the notebook. So right now the notebook is just spinning up here. I'm just gonna take a look at the cluster. Yeah, it looks like it's just starting. So we need to give it a minute or two for this to kind of kickstart it here. So one thing, again, just to verify is our parameter is at midnight, right? Even though we passed in the 15. So the subtract it is working perfectly fine. In this case, we don't expect any data to be updated. All we expect is a new version created, but with no data changes, as we ran through this code a number of times already. Okay. We'll be wrapping that up pretty quick. Just one more thing to note is that as you can see, there's no way for me to stop the run or run this cell by cell. As we discussed before, this is all ran, the whole notebook is ran as a whole. There's no capability for me to stop it, and that's why it's running as a job cluster in this case. And as soon as this job finished, the status will be successful, and the cluster will be terminated as well immediately. Okay, so while we're just waiting for that to finish, it is also going back to the Azure Data Factory. Since we have two activities inside the true block of the code, they're actually running under two separate clusters. So it's important to understand that because it does takes time to spin up a cluster like you guys are seeing at the moment. And that is that can cause a lot of delay if you know if you're experiencing any if you guys want this to run very much efficiently. So this is just I'm just doing that for demonstration purposes. In the future, when in the next session, where we will separate out the dashboard refresh, so that it's not going to be embedded in the run here in the next session. So, all right, now looks like the process has been completed. So I'm just going to go have a quick look again. A new version, yep, has been created. Again, like we expect, there's no changes as well here. Now I'm going to navigate to the notebook that we ran last. And this is the dashboard notebook. I want you to just remember this. This number is 13, just under 1300. So even this notebook in Azure Data Factory is running, and most likely is being updated at the moment. This notebook is not getting changed. So that is not really a good expected behavior that we want to have. But it's important to note that the notebook refresh run doesn't get refreshed in the notebook itself. It's a separate item that gets tracked and used. So if we click on this, the workflow side of things, and then we can, looks like the command has been ran, so we can come into here and select the dashboard. Now the number will be the same in our case because no changes has been applied with this notebook or with this time slice, but it is the data is pretty much being kept separately, which is not ideal because there's no easy way for you to come in Databricks to just see a dashboard. You have to go through Azure Data Factory to see this. Okay. Hopefully this has been succeeded. So let me just bring this back open again. It's not being nice. There we go. Now the visualization came back up. But yeah, so this is kind of kept separately. So if I even come into here and clean all my results, which we can do that really quickly, clear all cell output, let's say, right? This is not gonna impact the results in this notebook. So if you prefer to have the isolation, so this is good, but just knowing that the changes won't be applied to this dashboard on its own. Okay, so there's quite a bit of a pipeline needs to run. So I don't think we can sift through all of these changes for the demo, but yeah, just be aware that all of them has to be ran through for the next little bit, as it will be it will take some time to run, and it is marked successfully. So then move on to the next one here. Okay. So with that, we'll quickly wrap this up, and then we'll jump into the second Q&A here. So after all of this, we ran through the best practices on when to use each type of Databricks cluster. We have seen the interactive cluster that we initially tested a notebook with or developed a notebook with. We ran the job clusters a number of times in our integration or scheduling it out with Azure Data Factory. We talked a little bit about the costs associated to them and how this would impact in terms of how much Databricks costs to use. We created a notebook with a parameter to help us process our data. So we generalized the code so that it can be run for any time window that we like. We write the data out into the process container using the Delta Lake format. And as you saw in our demo, we has a table-like features, which allow you to make changes without having to rebuild the table altogether. We also created a table using the data in the data lake for the dashboard. So it's very easily to query with a SQL. And if you have a traditional data analysts or people that are more familiar with SQL, that's a great way for them to use Databricks as well. And finally, we schedule the our Databricks notebook in Azure Data Factory using the tumbling trigger. Yeah, so all the code you guys saw on the screen, they're available in my GitHub repository, and this is the at slash Wilson dash Mark slash demo is the repo, and you'll be able to find all my presentations there as well. So now with our data pipeline and dashboard refresh automatically, we can see our results. The next part of the series will dive into building a Delta Lakehouse along with using the Databricks SQL warehouse with using the medallion architecture on July 29th, I guess, in the India time zone, or the 28th at night in the North America time zone.